So in control unit, there are two things basically. One is hardwired control and second one is operations control, that how we can control the operations between this. So in control unit, we will discuss about the control of the signals, that how we can control the signals by using circuits, sequentials and combinational circuit. We discuss about the combinational circuits as well as sequential circuit earlier. So here we will study about the hardwired control, in which we have to discuss that how we can control the signals. So this is a diagram. By this diagram, we will try to understand that how we can control different parts. This is combinational logic unit. This is combinational logic unit. Means all the processes are going to perform over here. You can see this is from D0. This is from D0 to D7. D0 to D7, as well as these are 8 bits. These are 8 bits to select the data lines. This is the selection bit. This is used to select the values in the register, that what the values there should be. In last one, I told that input registers. Input registers are connected directly. Input registers are connected directly with the processing unit. With the processing unit. So when we have to produce the control signal, then in this side there is a instructions register, there is a instruction register. We know the length of instruction register, that this is 16-bit instruction register. 16-bit instruction registers. Last bit is for addressing mode. This can be direct or indirect. So this line, let me clear it once again. So this line shows that it is a direct addressing mode or it is a indirect addressing mode. This is the specific line for this one. This is the address line. This shows the address line. These are 12 lines. These are 12 lines. I saw only by one. So this is the combination of 12 lines. Then is opcode, there are 3 bits are left. Bit number 12, 13 and 14. By using these 3 bits, we can produce 8 different symbols, 8 different symbols 0, 1, 2 to 7 by using a decoder of 3 by 8, where in this decoder 3 are the inputs and 8 are the output. 8 are the output. So it select that what is the operation we have to perform. It select the operation at which selection we have to perform. From this is also a decoder as well as a sequence counter. What happens in sequence counter? This controls the sequence and it keep track that what is the address or which is the operation by address we have to perform. As this line, this control tells that By applying this means when the clock is 1, when the clock is 1, or when we are applying the clock, then operation should be performed. Either it will be a kill. So this is for the clear operation when we have to clear the data, and this is for increment operation. So these are the different operations. These are the controls for to perform different operations. This is a sequential control, sequence control. From here, as this is a decoder of 4 is to 16, means we can put the data from these T0 to T15. These are 16 lines. These are 16 lines. By using these 16 lines, we transfer the data. We transfer the data values or signals, and by these 8 lines we transfer the operation, that what's the operation or what's the operation this circuit has to perform. Then after applying all these in a desired manner, we get the control signal. So this was the control unit, that how we can produce the control signals by using different inputs. So when we are discussing about the control instructions or machine instructions, then there are 4 things. Each and every machine has 4 things in execution of a instruction. First one is fetch, to fetch information from a register or a memory, to fetch an instruction from a register or a memory, to decode that instruction. To decode that instruction, as I told you that if we want to add two numbers, then there is no need to write binary equivalent of add. We will write only add. So machine has to decode this from add to 0101 or in the binary form. So this is the work of the machine. So this is decode. So first fetch, then decode, then third one read the effective address, means at which address we have to perform the work. That can be direct address or that can be indirect address. And in the last, we have to execute the work. So there are 4 steps in each and every instructions. First one is fetch, second decode, third read, and fourth is execute. And after this, the processor goes on the first instructions, means this is a cyclic instructions. This is a cyclic instructions. By reading, executing, and working on first instructions, it reads second, for after that third one, and so on. So this is most important: fetch, decode, read, and execute. These are the instructions cycle. Now, timing and control. As I told you in the last also, that everything happens with a clock pulse. Everything happens with a clock pulse. If we will go in last also, in last slide also, then we can see from here that the operations are going to be performed with clock, means when this clock give the signal, that time operations are going to be performed. So now we will discuss about the clock, that how the signals are going to be produced, and when the operations are going to be performed, those are depend on the signals and the timings of the signal. From here, we can say that this is a clock, this is a clock, this is a cycle of a clock, this is one cycle of a clock, this is one cycle of a clock. So for first cycle I wrote T0, this is another, so I wrote T1. So these are different cycles, these are different cycles, the T0, T1, T2, T3, T4 and T5. Now this is a data line, suppose D3, and this is a line, clear line, this is a clear line. Now we will try to find out that how the operations is going to perform between timing signals or between the clock and the information. See here, this is T3, this is T3, and over here this is T2. If I want to clear the D3, if I want to clear D3, in that case our signals means clock should also be high, clock should also be high, this should also be high. When I have to transfer clear to D3, clear to D3, or when I have to clear the content, that at that time clock should be high and this should be high. So when I'm see, when I'm saying about the clock, during this the clock is 0, the clock is 0, or the value of the clear is, when I want to clear, then at this time this is clear, means signal of this is going to be transferred from 0 to 1, this is also high, and from here we can see that this is also high. So the SC can be incremented or clear, SC can be incremented or clear. At time T4, at time T4, this is T4, SC will be cleared, this is SC, it will be, SC will be clear to 0, and D3 decoder output, D3 decoder output means output will be at D3, it will be active. So at the time T4, at the time T4, this is clear, and the value or address or data at the line D3 is active. So everything is going to be performed with timing signals. So signals as well as control lines should be in synchronization when one has to perform the data. From here also we will see that how the timings are going to be changed at time t0, at time t0, this is t0 and this is t1, this is t1. So when I am saying that this is t0 is 1, t0 is 1, this is 1 means S1 is going to be selected. S1 is going to be selected. The value of these are 0. When T0 is active, when T0 is active, in that case only this gate, is going to be selected, otherwise the value of this is 0 and this is 0. So this is 0 1 0, this is 0 1 0, and the value of 0 1 0 is 2. Means at that time a register that is connected with 2 is going to be active. So this is a register, this is program counter that is going to connected with T0 at time. So this is T0 equals to 1. This is S1 is active only. You can see from here that S1 is active only and S0 and S2 are 0. It means the content of PC, the content of this register PC is going to transfer to AR, means address register. Transfer of this, see when this is going to be select, at that time address in the program counter is going to be copied and it will be transferred to address register. Then at time t1, at time t1 means this is 1 and rest is 0. This is 1 and rest is 0. This is, it reads the memory. It reads the memory at a location where the address is written at address register. So it will access the address from the address register and transfer the control to same address in the memory. It will access the address or it will read the address from the address register and shift control to the same address in the memory. The value of program counter is going to increase 1 so that it tells that we complete these instructions. Now we have to start the next one. So this is T11, T1 equals to 1, means at T1 equals to 1. This is going to happen at T2, at T2. So we are sending the data. We are sending the data of 12 to 14, 12 to 14 to D0 to D7. And from 0 to 11, from 0 to 11, the address, the instructions register in the address register. The content of instructions register into the address register. And in instruction register, we write 1. It shows that we are going to access the indirect mode now. So if we want to discuss this in brief, then at time t0, at first time it selects the program counter, then the address from the program counter is going to be shifted to address register, then it transfer to the control in memory at the same address. When control reaches this address, then it access the content. It access the content from that address and put in instructions register. Put it in instruction register. This is the you can see that this is load. This is load and read is active. read is active. The value of the program counter is going to be increased so that next time it will be going to read the next instructions. Then content of instructions register from 12 to 14, that is opcode, has to be decoded, and that is going to be transferred to D0 to D7, means 8 lines, as we discussed here, this also in the last slide. You can see again, these are 3 lines, these are opcode 3 lines, that is 12 to 14, and based on this it's going to select the line number, means the operation that is going to be performed. So here also, here in this you can see that it's decode the instruction register from 12 to 14, that is 3 bits, and select from D0 to D7 any line. Then this is 0 to 11 is the address register, and IR15, we know the IR15 is for mode, that mode is direct mode or indirect mode. Now we will try to understand this by a flow chart. We will try to understand this by a flow chart. At time t0, at time t0, or when the t0 is 1. Here t0 is 1. So what happens when t0 is 1? We will come on the last slide. Yes, when t0 is 1 means this is 0 1 0. 0 1 0 means it's going to select PC. It's going to select PC. So let's come on the flow. So this is PC is going to be select. PC is going to be select, and the content of PC is transferred to AR. Transferred of transfer the content of PC to AR, then PC is going to be incremented. PC is going to be incremented by 1. It shows that this instruction is going to be complete. Now the content of memory at address register, we discuss here that the content of memory at this address, content of memory at this address is going to be accessed, and that is stored in instruction register, that is going to store in instruction register. From there we, from memory we read the content, and after reading the content we bring the content in instruction register. This is of 16 bit, so we know the first 12 bits, that is 0 to 11. The data of 0 to 11, that is these 12 bits in instruction register, is going to be read, and that is going to be write to address register, means from the last 12 bit, this is going to be copied to address register, and the mode, that is direct mode or indirect mode, from the last bit, that is MSB of the instruction register, is going to be 1, and this is the 12 to 14 3 bits. This is for the opcode, that what's the operation is going to be performed. Suppose we select D7, so it will check that D7 is going to be select or not. If it is memory reference, we discussed that these can be three type: memory reference, register reference, or input output reference. Then if it is memory reference, then it will go in the memory. If it is register or input output, if it is register or input output reference, means if the value is 1, then it will check for the value of I, means bit number 15. Then at bit number 15, it will check that it is a direct register or it is indirect. If it is 1, means this is a indirect operation, or it will access the value of from the register indirectly, means from the reference. And if this is 0, means it will access the value from the memory directly. So when it is indirect, it's going to access the content from memory at register AR. If it is from the register, then execute register reference instructions and put the value of 0 to SC. So we can see from here also that this is D7IT3. D7IT3 means at time T3, the content of memory, at register AR, means address. Content of this is going to be transferred to address register at D7. Here we are saying that this is D7. So D7 IT3. This is I, or this is T3. And this is D7. This is D7. When I am saying that dash represents 0. So this is D7, and this is I, means indirect. It is doing nothing. So I will tell you this flow once again. At time T0, it transfer the content of PC, that is program counter, to address register. At time T1 means in next pulse. In next pulse, the value of program counter is going to be increased by 1, and it put the memory pointer. It puts the memory pointer at AR, or it access the content from memory at address register AR and transfer it to instructions register. Then we check for the direct or indirect mode. We check for the opcode, that what's the operation we have to perform, and then address register. We'll check the value of the operation, that D7, we have to perform D7 or not. If we have to, if this is register or input output, then the flow will be in this side, otherwise it will select the memory reference instructions. So this is D7 dash. D7 dash means this is D7 and this is dash. Dash means 0. So this is this one. And IT3. IT3. So this is I and this is T3. This is I and this is T3. So this is going to access the memory at this time. So it seems to be little bit different in first time, but when you will revise it, once, you will see that this is not too much difficult, or it will be more clear to you. Now about the register reference, we saw in the last slide that these are the memory reference, register reference. Earlier we discussed that the instructions type are three type, that this is register reference, memory reference, and input output. Not this one. Yes, this is instructions format are of three type, that is memory reference, register reference, or input output reference. Yeah, input output instructions. So here we will discuss about the register reference instructions, that how the values in the registers are going to be changed, or how we can perform the different operations on the register. In the last slide, we say that SC, we put 0 in SC, means we are going to start the process. When we start the process, suppose it's represent R, then accumulator, when we are putting a value 0, or when we are saving 0 to accumulator, means we are clearing the accumulator. We are clear the accumulator. Means the values, those are in the accumulator, we are setting all the bits to 0. This is clear. Now we can perform these all operation, that is clear E. Clear E, we discuss about the E also, that what's the E. The complement of accumulator, the content of accumulator at B9. The complement of E, this is complement of E, this is circular right, this circular left, this is increment, the accumulator by 1, and SPA, this is positive, P is for positive, means increment the counter 1 by 1, or this is for narrative reference. This is we have to increment the value of program counter if this is the value of E. The value of E register is 0. And when the accumulator is 0, at that time we are incrementing the value of program counter. And as I told you, halt means we are going to stop all the operations sometimes, then we have to insert the value of S0, or S is a start stop flip flop. When the value in S is 0, means it's working properly, and when we put a value 1 high, it means that the circuit is going to be halt or there is some problem in the circuit. As we discuss in the last to last slide, we have to come back because these will the things that will be clear to you if we will take the reference from the earlier. See, from here, instructions register, when we are talking about the opcode, then in opcode there are 3 bits, 12, 13 and 14, and by the combinations of these 3 bits, by using a 3:8 decoder, we can produce 8 outputs. So these are different operations. These are different operations those we can perform. So now we will discuss about these D0 to D7. So let us try to understand about the D0 to D7 control lines, that what's the operations we can perform on these. When D0 is going to be selected, when D0 is going to be select, means we are performing the AND operation. We are performing the AND operation where AND of accumulator and from the memory. How we will came to know that at which point the address pointer is? The address is written in, we know that address is always in AR, address register. So what we will do, or what system will do, it will go in the memory at the register. It will go in the memory at this register, address register, and access the values from the memory, the content from this memory, and it will perform a AND operation with accumulator, because we discussed that all the operations are going to be performed in accumulator. So this is doing the AND operation with memory and accumulator. This is add. D1 is going to produce add. So add of accumulator plus memory content at address register. And here you can see that we were there, we did not discuss about the E. E is a register. E is a register that is connected with accumulator. You can see over here. I will tell you. I will show you. So in this circuit, you can see here that E is a register that is connected with ALU, arithmetic logic unit, and we perform the operations over here. So now you came to know that where we have to use the E. E is for the maybe overflow or to set some values, from where we came to know that what's the next decision control has to take. So now on the same slide, yes, this is now in E register. In E register, value is C out. Value is C out. Then LDA means load. Load the value of memory. Load the value of memory at address register R to accumulator. to accumulator. STA means store. STA means store. Store the content of accumulator to memory shown by address register AR. This is branch. BUN branch means transfer the content of address register. Transfer the content of address register to program counter. This is we have to transfer the content of program counter to memory register. We have to transfer the content of program counter to memory at register represented by address register, and we increment, after that we increment address register by 1. Then we have to initialize, we have to increment the value, we have to increment the value when memory address, if memory address plus 1 is equals to 0, then we increase the value of program counter 1 by 1, and we increase the value at memory AR by 1. Means at that time we are incrementing the content, or we are incrementing the value of memory at register AR by 1. So this was about the different operations. Those are going to be performed. Then add to AC. We discuss over here add. But this was about the AC. So what happens when we are going to access the content of memory from register AR, means this is a register, address register that contains some address. So we are going to access the content of this address, and we are putting it into DR, that is data register. So we access the content of memory at this address and put the values to data register at T4. At T4, this is time, this is clock signals, that T1, T2, T3 we discuss, and this is D0 means operation, whatever the operation we have to perform. We discuss these operations also over here. You can see and 0, add 1. So we are seeing this over here, that is D0 means we are doing add, D1 and D1 we are doing add to AC. Accumulator means everything we have to perform in accumulator. If we want to explain that here completely, then this is the complete operation that is going to be performed. Means at the time of read operation, first the data is going to be accessed from the memory and shift to data register, then a AND is performed between accumulator and data register, and is performed between accumulator and data register, and the value, that is AND operation value, is going to be transferred in accumulator, and value of SC is 0. When we have to add the content, this is same, only the operation is different, that is D1. Earlier it was D0, D0 was for AND, D1 is for add. So it's putting the content of this memory to data register, then adding the content of data register to accumulator, and putting the result in AC. Then C out, whatever the values of C out is, that is sending to EC, and SC is 0. Means store a carry in AC. If there is carry, then it will be 1. If there is no carry, from by the adding of AC and DR, then this will be 0. So it happens in the case of and add. Same, this is also in the case of LDA, that is load, store, branch, and branch. You, when we will come on the last to last slide, you will see here we discuss about and, add, load, store. Now these are the complete explanation of those operations. This D2 is for the load, D3 is for the store, this is D4 is for the branch, unconditional branch, and B, this here will be, sorry, here will be D5. Here will be D5. It's by mistake. D5 and T4. D5 and T4. This value will be, this value will be over here. Over here. So when LD means this is active at T4, at time T4, memory is going to be accessed at address register, and the value is going to be transferred to data register DR. Then this value is going to be transferred to accumulator. Same, the value of accumulator is going to be saved in memory. Save in memory. This is an unconditional, and this is also a branch operation. So I think this is sufficient today. Let me check how much is the left. Lot of things are left. So we will do till input output instructions. Yes, we will do till input output instructions. We will complete the memory reference. So this is the thing we have done. Now we will try to understand this, that what happens inside the memory. What happens inside the memory? In memory, this is the next instructions, means PC will be at 20 earlier. PC was at 20 earlier. So when we will do PC plus 1, so it will be 21. When we will do PC plus 1 means when it will be on the next instruction, then it will be 20 plus 1 means on the next instructions. Then this is a address register. At time T4, the address register has the value 135. Over here also, when the time is T4, this is also at the memory location 135. So there is a subroutine. Here is also a subroutine. Then what's the difference? The difference is that this is the content earlier, means before execution the instruction, and this is the position after the execution of instructions. When earlier memory is included, program counter is included, and address register is also included. But later on, means after execution of instructions, there is no need of the address register. Means it transfer the control to the address at the particular address in the memory, and then we can say that after execution of the instructions there is no need of the address. So this was when the instruction is going to be start, and this is after accessing the instruction. This is again BSA that we done this. This is this one, yes, BSA. These two are left over there. We did not discuss BSA. No, we did BSA. Yes. Now, if we will try to understand this memory reference instructions from here, see, try to understand it very carefully. We are, this is in parallel with this because there was no space, so I took them below. Otherwise it is also same in the same level, that is bun. Bun means what I am doing, I am writing this over here, so you should think that it is here. This one, that is BSA, is at this place, and this is ISZ is at this place. Means I am dividing the memory instructions in 7 parts. We discussed this earlier also, that based on this, based on D0, D1, D2, D3 till D7, till D7, that is D4, D5 and D6. We have to select different operations. So here we select add operation. At D0 it's going to select add, sorry, and this is add, load, store, branch unconditional, and like this. So I am trying to specify these. I am trying to specify these, means the steps those we study earlier over here. You can see from the last step that when we are accessing the AND operation, then first we are sending the content of memory at DR, then we are doing the AND operation of AR and DR and AC. Last also we discuss about, we did this, you can see here, not this one. When we are doing add, then D0 represents the add, D0 represents the add. First, we pick the content of memory at this location and put that in data register. We perform the AND of data register with accumulator. We are doing the same thing over here also. Means this is the summarization. This is the summarizations of all those. You can refer from there. If you have some problem, then we will discuss. Now, input output instructions. We will discuss about the input output instructions in the next lecture. So today we discuss about the memory reference instructions. Till memory reference instructions means we did instructions code, computer registers, computer instructions, timing and controls, instruction cycles, memory reference instructions, register reference instructions. Now we will discuss input output instructions and design of arithmetic logic unit in next class. Thank you.